Now let's try to find a specific expression for variation of pressure in the atmosphere. Okay, now the atmosphere is different. When we were talking about this one little box, the atmospheric pressure didn't change much, or gravity didn't change much, or the density didn't change much, right? So variation of pressure in the atmosphere. So what are the things that change when we go higher up? Well, one thing we know as we go higher up, its gravity will change. Acceleration due to gravity will change as we go up. The density of the atmosphere changes significantly. Temperature also changes, right? Now, how do we handle situations like this? Well, we're going to make our life a little bit simpler, and we're going to say, yeah, I know gravity changes, the acceleration due to gravity changes, because the force of gravity changes, the acceleration will change, but I'm going to pretend that that doesn't affect my calculation. Okay? So I'm going to take this out of the picture. I also am going to say, okay, yes, I realize that the temperature also changes, but I'm going to say, well, according to my calculation, the temperature change is almost negligible. Understand it's not true. I am totally lying. But I'm going to say it's going to be negligibly different, right? Okay, so the only thing I'm going to worry about is the change of density. We know that the density changes proportionally to the pressure change. Which means if I say rho is proportional to P and rho zero is proportional to P zero, may I combine these two equations to write that? If two things are proportional to each other, can you divide the two equations? Yeah. And change the proportionality signs to equal? Okay, which means may I write this as rho zero over P zero P? Then I go back to my handy dandy equation that I developed. I'll call this equation A. Oh, I want to call it something fun. What do you want to call it? Cat. Okay. E. Make a bat. I can't make a bat. I can make a cat. So I'm going to do a cat equation. Okay, so I'm going to draw that cat equation again. Right? Our cat equation again will give me what? dP over dy equals minus rho g. But my rho is no longer constant. So what do I have to do? To plug this in here? That means I will get dP over dy equals minus rho zero over P zero small p g. There is a P on this side and there's a dP on that side. So that needs to move there. And then dy gets to move on the other side. So what will I get? 1 over P dP equals minus rho zero over P zero G dy. May I integrate? P zero, rho zero at sea level are constant. G is constant at sea level. Just the dy is changing. So 0 to y. This would be sum P0 to P. Integrate. What is 1 over P dP? Integral. Natural log. Very good. That means this would be log of P over P0 equals minus rho 0 over P0 G y. I should have called it H. Actually, may I change it to H? I changed my mind. Y still looks like a variable. Change it to H. So we know it's a number. It is the height we are looking for. Now, how do I get rid of the log? So may I write this as e to the minus rho naught over p naught gh? And sometimes all of this is written together, and we write it as A equals P0 over G rho 0 to give us this expression as P equals P0 E to the minus H over A. Because P0 is always 1.01 times 10 to the 5 Pascal. G is always 9.8 meters per second squared. And rho 0 is 1.21 kilograms per meter squared at 20 degrees Celsius. So plug all of these values in. A is calculated to be 8.55 kilometers. You don't have to recalculate it over and over again. Everybody good so far? Okay, one last thing. If you plug all of these numbers in, what do you find? At altitude, about 20 kilometers, which is not a lot, your atmospheric drops to 0.1 atmosphere. We will die. At 40 kilometers, the pressure drops to 0.01 atm, and we will certainly die.